Hi everybody, we're doing 3.6 chain rule. This is Miss Rosita. So chain rule is basically a function, you're using it to differentiate a composite function. So here, just to remind you of notation, this would be the function f of g of x. And so to represent the derivative, we put the little prime mark right here before the of x part. So f of g of x. And the way it works, let's see. The way it works is basically the derivative of the composite function. Oh, I'm sorry, I have to talk about notation again. So here I'm switching to the other form of notation for a composite where it's actually just embedding the g of x inside of the f of x. That probably is the more common way to look at the notation anyway. So the derivative of this, we would just put a prime way out on the outside of the whole thing there. So our definition of derivative of a composite function is that you take the derivative of the outside function, which is the f function of g of x, and then you have to multiply by the derivative of the inside function. So that would be our g prime of x that you see in red here. So again, the f of x is considered the outside function, g of x is considered the inside function, and it's the derivative of the entire composite would be derivative of the outside of g of x times the derivative of the inside. Okay, so what I did was I went ahead and took a simple problem where the outside function and inside function are pretty straightforward, and the composite looks like this. So we have just the quantity of 2x plus 3 being squared. So here my outer function is the fact that I have something being squared, and my inner function would be the 2x plus 3. So you can think of putting your composite back together. If I had f and g separate, I would take the 2x plus 3, I would plug it into f, and I would square it. So the composite does, in fact, look like this. So my formula here, I need the derivative of f at g of x, and then I multiply it by the g prime of x. Okay, so before, if we didn't use the formula, we would end up being able to still find the derivative. If I squared it all out and did power rule, I would certainly get my answer. But this is just an option. So if I am going to take the derivative with chain rule, the outer function is just the x squared. What's the derivative of x squared? It'd be 2x. Well, what's the derivative of f of g of x? That wouldn't be x, it wouldn't be 2x. It would be 2 times my g of x. Right? So 2 times 2x plus 3. And then I multiply by the derivative of the inside function, and the derivative of g of x is just 2. And so there it is. And then I simplified it and I got my same answer as I got over here. So this times 2 part is the part that we would consider the chain, because you're having to remember to multiply by the inside function's derivative. Sometimes when you're just first starting, this formula can be kind of a little confusing. So it might be easier just to kind of think of it with power rule. So here, if this is my equation, I'm trying to take the derivative with power rule. I see the exponent of 2, so I know the 2 needs to come down. I'm going to rewrite the thing inside and subtract 1 from the exponent, giving me 1. And then I just have to remember times the derivative of the inside. That's the chain rule part. So derivative of 2x is 2, derivative of 3 goes away at 0. Maybe that's a little bit easier way to look at it. Okay, so I have a whole bunch of examples. I'll just kind of run through them and see if you can kind of pick up on the pattern. So here is our new inside function, and the outer function would be that I have x to the minus 3 power. So when I'm looking at this function, again, if I think of it just kind of with power rule, the negative 3 needs to come down in front. I need to rewrite the inside. I need to subtract 1 from the exponent. And then the chain part is I don't want to forget to take the derivative of the inside function. That's the g prime of x part of the formula. So here, multiplying, derivative of the first term would be 10x. Middle term is negative 2, and the constant, of course, is 0. So the derivative of this comes out 10x minus 2. I put the part in red, which is the chain rule part. Okay, so we did a couple examples just now with the power rule. We call those power chain rule. But now you might look at trig formulas, since you had that in section 5 last night. So when I'm looking at cosine of 4 minus 3t, what's the derivative of cosine? Well, it's negative sine of this. But the inside function which in this case is 4 minus 3t, I have to remember the chain rule part, derivative of the inside function. So derivative of 4 goes away, derivative of negative 3t is negative 3. So again, in red here is the chain rule part, and I can of course simplify that a little bit to this. Okay. Next one. Another trig function, I have tangent of 6w, whole thing cubed. Just in case you're kind of rusty on notation, when the 3 is in the exponent right up there, that really means tangent of 6w, the whole thing being cubed. So if you think of it like this, then again, power rule should come to mind. So the derivative with power rule, the 3 comes down in front, I rewrite the inside, I subtract 1 from the exponent, and I have to remember the chain part. I have to take the derivative of tangent of 6w. So what is the derivative of tangent of 6w? Well, secant squared of 6w, again, chain rule, times derivative of 6w, which is just 6. So it almost seems like you're doing the chain rule twice, really, because you're not only taking the derivative of tangent of 6w, because that's the inside function, you're also, in order to take the derivative of that, you're having to take the derivative of 6w itself, getting 6. So a little confusing until you practice that a couple times. So, more examples. This one looks a little overwhelming. Let's see. So for the first one, first equation at the top here, this is our function. I don't really like seeing the root. I prefer to look at it with the exponent. It helps me when I'm doing power rule to think of it as an exponent, so I change the root to the 1/2 power. And then when I'm looking at it, I realize that what I really have is a product. I have something here with a t in it, and it's being multiplied by something else with a t in it. So I really have to apply the product rule. So I start off thinking, okay, I have the first thing, I just copy it down, and then I'm going to need the derivative of the second thing. So here, derivative of the second thing, plus the second thing times the derivative of the first thing. So this is basically what I need to do. So this part in blue and this in blue, I have to figure out what those derivatives are. So derivative of cosine of 2t to the 1/2 power is power rule to take the derivative. So a half comes down, rewrite the inside, subtract 1 from the exponent. But again, I need to remember my chain rule. I have to take the derivative of the inside function. So the derivative of cosine 2t. If I just keep following the blue down, so this first part, I just copied it. What is the derivative of cosine 2t? Well, it would be negative sine 2t times the derivative of 2t, which is 2. So all of that blue kind of just follows down. If I look at the other side here, the derivative of sine 2t quantity squared, again, power rule, 2 comes down, rewrite the inside, subtract 1, so it's the first power, and then chain rule times the derivative of sine 2t. What is the derivative of sine 2t? Cosine of 2t times the derivative of 2t, which is 2. And so here's my lovely equation that I get. I simplify it and I get that. Okay, that was a long one. Okay, rather than giving it to you a problem where the composite is already kind of put together, sometimes they give you the composite separated. So here they have y is equal to u squared, and u is 2x plus 3. So if I wanted to, I could take the 2x plus 3 that equals u, and I could plug it in place of u. So I'd really have 2x plus 3 quantity squared. And if I like that better, I could just go ahead and do that and take the derivative like the previous examples. But just to show you kind of another option, I'm not going to put the composite together. I'm going to leave them separate, and I'm going to work with, oops, I keep skipping ahead here. I'm going to leave them separate and put them together later. So our question here is to find the derivative of y with respect to x. So here, if I take the derivative of this equation, just without any kind of composite putting them together, just this one. So the derivative of y, but I have u in the problem. So this isn't really going to give me dy dx, it gives me dy du. U is the variable over here. And the derivative of u squared would be 2u. Over here, if I kind of do the same thing, if I take the derivative of u, I'm going to take it with respect to x because that's the variable on the other side. So I have du dx. And what is the derivative of this side? Well, derivative of 2x is 2, derivative of a constant is nothing. So what I have now is kind of individual pieces. Then what I'm looking for is dy dx, And if I just kind of think of these things as fractions, I have dy du times du dx. If I multiply them, my du's would cancel out, and I would in fact have dy dx. So if I go ahead and take my 2u and multiply it by the 2, I get 4u. And then the only thing that's left to do is my original problem is in terms of x. They're asking me for the derivative of y with respect to x. So I don't want to leave a u in the problem. I want to go ahead and substitute out what u equals. So 2x plus 3. I've got my answer. So you probably have a preference one way or the other. Most people do it the other way, not this way, but you should be at least familiar with both ways in case on the AP exam you see a problem that looks like this in the multiple choice section and you really have to kind of work with it separate. Okay, so kind of going along that same theme, we're going to be asked to find the slope dy dx at t equals -1/6. And instead of giving me x and y together in one equation, they're splitting it up into parametric equations. So here I have an expression for x in terms of t and an expression for y in terms of t. So if I take the derivative of this part here with x, I'm going to take the derivative of x, but it's going to be with respect to t because t is the variable over here on this side. So I get dx dt. What is the derivative? Well, again, I have sine, so the derivative of sine is positive cosine of the angle, 2 pi t, and then chain rule times the derivative of 2 pi t, which is just 2 pi. Remember, 2 pi is the coefficient of the variable t, so it's just 2 pi for the derivative of 2 pi t. On the other side, the derivative of y with respect to t. So here I have the derivative of cosine is going to be negative sine of the angle, and then times the derivative of the angle. And again, the derivative of the angle will be just 2 pi. So here I have dx dt, and here I have dy dt. What I'm really looking for is dy dx. So if I think about how I can make dy over dx come out, I would basically do a little fraction. So dy dt divided by dx dt, these dt's in the denominators could cancel out, and I would get dy dx, which is what I want. So I just need to put this over that. And all of this on the right side, I'm just simplifying it. The 2 pi's cancel out. I'm plugging in the t value that they gave me, -1/6 in for t. Kind of simplifying it a little and then recalling from my unit circle what these values equal and simplifying all the way down. Comes out nice and clean, root 3. Okay, so we've made it to the practice problems. There's just 3. Please go ahead and hit pause, give them a try first, and then when you're ready, go ahead and play. I have the answers after. Okay, so here's the answers. For the first one, we're given the equation f of x looking like this with roots in it. I would suggest go ahead and rewrite it with the exponents instead. It really looks weird to see a root inside of a root anyway. So when I'm looking at this, I'm supposed to be taking the derivative. This whole part on the inside is my g of x function. The outside function is just I have something to the 1/2 power. So I'm going to start with my power rule. 1/2 comes down, rewrite the inside, subtract 1 from the exponent, and then chain rule. I have to remember to take the derivative of the inside function. Derivative of 4 is just 0. Derivative of this part, well, power rule again, so 3/2 x to the -1/2. I just kind of cleaned it back up, so negative exponent drops it to the bottom. Again, this negative exponent in the bottom, and the 2 times 2 makes 4, and there it is. Okay, the second one, the 2 that's out in front, I just left it alone. But again, this squared up here, I prefer to see it on the outside to make sure I'm thinking of it as quantity squared, power rule. So when I take the derivative, this 2 comes down in front. 2 times 2 is 4. Rewrite the inside function and subtract 1 from the exponent. It makes it just a 1, so I didn't bother putting it. And then chain rule, I have to take the derivative of the inside function. Oh, you guys, I messed up. Hold on. Okay, so I fixed it. So again, the power rule now, the 2 comes down, that's 4, secant of x to the 7th to the first power, and then times the derivative of the inside. That's where my mistake was. So the chain rule part, the derivative of secant x to the 7th, that in itself is like a whole problem, because the derivative of secant is secant tangent, but then times the derivative of the angle, which is 7x to the 6th. Okay, and then from here I just kind of cleaned it up to this bottom line here. Yeah, that's kind of a little bit tricky there, just remembering that you have to take the derivative of secant x to the 7th, and that is secant of your angle, tangent of your angle, times the derivative of the angle. Okay, last one. So it says, given that the derivative of f is this and g of x is that, find capital F prime of x if f of x equals this. Okay, so for starters, f of x, capital F of x is given to be this, and they are asking me for the derivative of that. Well, that is a composite function, f of g of x. So again, our definition of the derivative of a composite function is our chain rule that we're doing today. So the derivative of f of g of x is f prime of g of x times g prime of x, the chain rule part of it there. So really, I just have to kind of plug things in where they go. So g of x is right here, so I'm going to replace g of x with root 3x minus 1. So really what I want then is f prime of this times g prime of x. So I want the derivative of this, prime of this thing. So for starters, what is f prime of this? Well, f prime of x is this, so if I replace x with my g of x part, f prime of root 3x minus 1 will be root 3x minus 1 over root 3x minus 1 squared plus 1. And that's what all of this part here is. And then the derivative of this part here is a power rule. It's a 1/2 power, so power comes down a half, rewrite the inside, subtract 1, derivative of the inside is 3. Okay, and then square root squared cleans up nicely and it simplifies well. That was the last one. I hope that helps for your assignment tomorrow in class with chain rule. This is a really important section, so it's going to take a little practice, but eventually you'll probably get pretty good at it. Okay, thanks.